This question talks about an elevator which has a mass of 4,850 kilograms. Is to be designed so that the maximum acceleration is 0.068 g. Where g is that definitely the acceleration due to the gravity. What are the maximum and minimum forces the motor should exert on the supporting cable? So we're gonna make two cases over here. This is the first case where this is the elevator. Let's make it again. So this is the required elevator, this is the tension, and this is the weight. Now in case one, this is going up with acceleration of a, and this is in the next case it is going down with an acceleration of a. Let's talk about the case one. So in the case one, if you're going to make the equation of the motion, that's going to be t minus w is equal to mass of the acceleration, mass of the elevator times the acceleration. So the tension is going to be, which we have to find, is going to be W plus MA. Now, for the tension to be maximum, why we are taking this as a maximum? Let me write the equation for the second case as well. It will make more sense. In this case, W minus T is going to be equal to MA because the acceleration is pointing downwards. So if you're going to rewrite T, then T is going to be W minus MA. So we can clearly see that in these two equations, this is going to result in a higher value of T since this is W plus MA, and this is going to result in a lower value of T since this is W minus MA. So from this, we are going to get the maximum value of T, and from this, we are going to get the minimum value of T. Now the point is, when will this be maximum? So this will be maximum when, see, W is a constant, mass is a constant, acceleration is the only thing which we can change. So this is going to be maximum when acceleration is going to be maximum, and the maximum acceleration is already given over here. So let's put the value of let's replace W by mg, and this is ma, ma, where a is the maximum acceleration. So m is taken out, we are left with g plus a max. Now let's substitute the value of m over here. Mass is going to be 4850, so this is 4850. G is going to be 9.8 plus the maximum acceleration is 0.068 g. Okay, if it is in terms of g, then let's keep this as g as well. Let me grab my calculator here, and this is going to be same as let me just find it, 1.068 times g times 4850. So that's going to be equal to 50762.04. So this is the maximum tension which the cable can support, and definitely the unit is in newtons. Likewise, the same thing which we are going to do over here as well. So the only thing in this complete equation is the sign is minus. So this is going to be mg minus ma minimum. So this is going to be m times g minus a minimum, again is 0.0 the maximum. This is not going to be minimum. So there is another thing mathematically which we have to understand over here. This will be minimum. This will be minimum when the only parameter which is changing again is weight and mass is constant. The acceleration is the only thing which is changing. So if we have to make this minimum, then this part should be maximum, so that we subtract the maximum thing and we get a minimum value. So again, acceleration is going to be the maximum over here, which is already given to us as 0.068 g. So we know the value of mass, it is 4850, and g minus 0.068 g remains as it is. Let me just grab my calculator and find this. So that's going to be equal to 1 minus 0.068 times g times 4850. So that's going to be equal to 44297.96, and the unit is Newton. So this is the minimum value of the tension for the cable. So these are the required minimum and the maximum values of the tension or the forces the motor should exert on the cable. Thank you.